artificial intelligence really has a huge potential in addressing lots of urgent societal issues. AI might be able to help us use more renewable energy. It will help us use transportation more efficiently. And in disaster response, AI can help us allocate limited resources, so for example, first responders or medical care, to those people who need it the most. However, we won't be able to get the benefits from these new technologies unless people are able to trust these AI systems. And that's why we have to get them on board right from the beginning and design our AI systems in a citizen-centric way.
We believe that it's important that AI systems are aware of preferences of citizens, and then they're also auditable by these end users. It should be clear why they made such decisions. So in this way, we are trying to build citizen-centric AI systems that are not only aware of preferences, but they also provide explanations to end users so that it's clear why those decisions are made by AI and that those decisions are in favor of end user citizens.
To guide our research, we've chosen 3 separate application areas. One is smart energy, the second is smart transportation, and the third is disaster response. We've chosen these 3 application areas because I think they offer potentially the most significant positive benefit from using artificial intelligence in the future.
And then this is the graph for the actual results.
I'm Behrad. I look at how we can use dynamic and adaptive pricing and incentive schemes to make road systems and networks fairer for society as a whole. If you were to get the train, for example, in London, it would be busier, right, at certain times. So what we do is we look at ways of pricing these and providing incentives for people to change their behaviour, to travel at different times or to take different travel methods in order to sort of balance the load across them. And then that way we can use the infrastructure that we've already got to make our transportation systems a lot more effective and fairer, actually.
I'm Jan Böhmann, I'm a research fellow on the CCASE project, and I'm working on incentivizing the efficient uses of resources. In this particular example, the M6 toll is a fixed rate, independent of how much traffic is on the M6. So you pay the same fee even if there's no traffic on the M6. Another problem is that the social problem that you have to be able to afford the additional cost. Those people who might not have the funds available will more often spend their time in traffic. So one option would be to make it more variable, so that depending on the traffic on the M6, you would have different fees on the M6 toll that kind of adjust so that there is more of a balancing between the 2 roads. So that's just one example of the many areas where incentives and resource play a role, like the electricity grid, public transport, and so on and so forth.
So how will you interact with these future AI systems? Well, our vision is that you will have a personal AI agent, which is a bit of software that works purely on your behalf. It might sit on your mobile device, and most importantly, it doesn't share your private information with big companies, but it keeps it safe, again, say on your mobile device, and then uses that to act completely to your benefit and on your behalf.
This is the driving time and charging cost. So my research is about finding charging stops for electric vehicle drivers, especially on their long journeys, based on the preferences of drivers using AI methods, saving money, saving time, or accessing to specific facilities at the stations along their route.
I'm Alex. I'm working on making citizen-centric demand responsive transport more accessible. So by improving the accessibility of the system and the networks in general to actually serve the proper populations, we can do things like reduce emissions, reduce congestion, and overall reduce reliance on the car as a necessary feature of the British family.
So my area is in audio AI. So I look at things like how audio can be made safe to equip smart buildings with a variety of different audio AI services. So another project that I work on is called Tame Pain. And here we are looking for bioacoustic markers of pain in the speech signal. And that has direct relevance to any kind of phone call. So NHS 111 is a great example of that. if we can identify bioacoustic markers of pain in the speech signal itself, we can provide a lot of different services to people to help them.
The project is a UKRI Turing AI Acceleration Fellowship, which is for 5 years, and we're roughly halfway through the project at the moment. We've achieved a lot in that time. We've written papers about our algorithms, and we've run workshops with stakeholders and established a new seminar series on citizen-centric AI systems. We also have a spin-out company based on some of the ideas from the project, but there is still lots of work left to be done. And I think especially looking at recent developments with large language models, I think that's a real opportunity to build systems for people to much more easily interact with AI systems.